We're now going to go to the start of the printed circuit board manufacturing process. The manufacturing area is split into two divisions. One is printed circuit board manufacturing and the other is the systems. So some customers want us to manufacture printed circuit boards only, and we ship them as a finished part to the customer who do their own systems assembly. A lot of our business is manufacturing the printed circuit board, and then we put that printed circuit board into systems. This production line here, for example, is gas and water meters. So we make the printed circuit board and then we put that printed circuit board into the meters. A lot of the systems that we're manufacturing out here are video conferencing systems, whereby we can talk to each other from the other side of the world on a video conferencing. That may be on a small handset or it may be on a large screen. I would ask you not to do any close-ups of any of the products.
No problem.
Please.
Yeah.
Our printed circuit board manufacturing process starts here. That is what we call a bare board. It's a bare printed circuit board, but they're attached because it hasn't got any components on it. And one of the first operations we do to a board is put a barcode on it, like most of the items that you buy today. Barcoding. Our printed circuit boards are barcoding so that we've got traceability within our manufacturing process, and also when it's delivered to the customer, a lot of our customers got that traceability what's happened to that particular product, wherever they may use it or ship it. So we put a barcode label on this point here. In terms of material preparation, this is the area that's our kitting area. And what it is on that printed circuit board you might have 100 different types of components, all different shapes and sizes, silicon, chips, resistors, transistors, etc. All those, the information is provided from our planning department, all the material that needs to be kitted to make a batch. That batch can be anything from 20 to 500. And what this team here are doing is making sure that they provide a kit. That kit then comes out to this section here as a bare kit. And what their job is to fit all that material onto what we call placement feeders. So these feeders are important for the next process that you'll be seeing. Because the parts will be fitted onto the printed circuit board automatically via what we call placement machines. So we'll be picking each individual part up. You can see how small some of these parts are. Those are the sizes of parts that we're talking about. So this team out here is preparing for the surface mount process. Okay? What we have here now is state-of-the-art placement capability. Some of the components that we're dealing with today can be quite large, or they can be the thickness of a human hair, 6,000. We're actually picking those parts up, inspecting them and placing them on the board. These particular machines that you see at the moment have got the capability of placing 80,000 components per hour. temperatures, like 10 a second. Every second it's placed 10 parts. Not only has it placed it, it's inspected them and also placed them. Starting the process off, we have to do some clever things like manufacturing stencils. So we have to have a stencil. Of course, what we want to do is to put some solder paste down in the positions of the components, and then we'll put the components on top of the solder paste. So this is the same process that that Vega printed circuit board will go through. It's no different. Okay. So we're simulating now. When we're in production of the Vega computer PCB, this is the process that we go through to manufacture the board. The board goes in this buffer. You see the board's in there. We go through this machine where we paste the board. So we put some solder paste only in the places where we want the components to go. This equipment here will inspect to make sure we've got that process right. And as I was just saying, we're now putting the components down on the board. You can see the speed at which we're putting these components down. This is simulating the actual placement speed at which the rotary heads there are picking the parts up and actually placing them on the board. We have two placement machines, splitting them in between we break down the build in between two machines. Okay. Did you hear that? That's the placement process of picking the part up and actually placing it down. And you can see the parts on here that's actually being placed. That is the finish of the placement process. So there you've got a printed circuit board with all the components fitted, but it's all sitting in wet paste. If you touch that now, you can wipe all those components off. What we're now going to do is put it through an oven. Right, this is an oven. What we're doing is taking that board up to temperature, solidifies the solder, and then it cools it down. What we then have, at the end of the oven, all those components now are attached to that printed circuit board. And this piece of equipment here then will inspect all of those parts on the board to make sure everything is perfect. Everything is actually present, and it's making sure that we haven't got any that are through the process of turn.
What will it do if there is?
It identifies, comes up with a fail. That lady there is looking at any failures of either of these two machines. So we have a pass and fail rack. Anything that the machine recognises fails goes into a different rack, so it's all automatically captured. We have a range of equipment here which is 25 years old. We still have products we manufacture that isn't state-of-the-art technology. It's very old technology. To give you an example, the Belfruit, the gaming machines, one-arm bandits, if you look at the printed circuit boards in them, they all surface mount. They're all 25.
One-arm bandits, is that where you will start asking your questions, Nicola?
Okay.
The gambling man.
Surface mount lines here. We're now going to go to the prototyping
I noticed the room, you know, where you have all your parts back there.
Yeah.
So it's a lot like a post room, isn't it? It's very similar equipment to what I've seen in post rooms before now, for sort of mail sorting and things like that.
Storage.
Yeah.
It's an officer type storage. This room here is where we are preparing any components that are going to be fitted manually. So not all parts can be put down my machine. Any parts that are fitted manually on the board will have to be prepared, legs cut or preformed, etc. So we do that in this room here. This room here is our prototyping department, or development services. This is where we take customers' initial designs. Customer comes up with an idea, an invention, a bit like Sinclair. He doesn't want 200 making. First of all, he wants 1 making. Then he wants 5 making, and 20 making. So he gets the confidence in the product. That's what we do in here. It's a small manufacturing. Exactly the same processes out there. Printing, placement, reflow. But for quantities of 1, 5, 10 typically. Once they've gone through all that development stage and we're now happy that we've got a good manufacturable product, that's when the customer then says, right, I now want you to make a pen. And that's when we start looking at that process. This is exactly what the Vega's gone through. The Vega computer started live in here, doing 1 off, then 5 off. We're now at the stage where we're planning on doing thousands. So those thousands will be done on those high volume lines, and I'll show you where the assembly will be done a little later. We have to have facilities, we have to have good facilities for putting components on the board, but in terms of having to remove the components or any modifications, we also have to have the skills and the capability for taking those high technology devices off the board as well. And that's the department that we do it in there. So some very high level of skills, some very sophisticated equipment for the removal. What we have here is, this is our analysis department. So the technology of products that we have today, we need to do some analysis on them to make sure that all the geometries are correct, that we have got good adhesion, failure analysis. That's what happens in here. That machine there, for example, is quite an expensive X-ray machine. So we use X-ray for looking inside of components or lead attachments, etc., on the latest technology of parts, not for X-ray of the human body, although it's capable.
Which would be more fun, of course.
It is more for establishing whether that product we've manufactured is a good product. So a range of equipment in here, X-ray inspection. There's some destructive tests we can do here. We cut products in off and do a cross-section analysis, etc. And very important to make sure that we've got the quality assurance of that particular product. Following on from the printed circuit board manufacturing process, because what we've done there is looked at the ancillary prototyping and the analysis. The boards that come through surface mount, they haven't got all the parts surface mount design, which very few components usually have. You might have 1 or 2 connectors that have to be fitted by manually, or a range of components that can't be put on by surface mount. Then we have to have the capability of what this team are doing here. They're fitting all those hand-fitted parts that were prepared in that room down there. They're now building them in sequence. You can see all their instructions on the screens, which are automated. Gone are the old-fashioned folders with instructions, engineering supplied online. Heard you mention the one-arm banding machine. Well, that is a typical product for that is for that particular printed circuit board will go inside of one-arm banding. And as I said previously, it's got some surface mount, so they have advanced somewhat. It has gone on those machines, and there are a few components that still have to be fitted by hand. So that's a sequence of 3 operations: surface mount, automated machines for putting through holes in the boards automatically, and the third stage, manual assembly. Anything that's fitted manually, we've then got to go through and solder them, so we have to go through a wave solder process. And to put them through that process, we then have to have specific fixtures to hold the product. So that's the wave solder. So the boards, when they come out of there, if I can take that one there. Anybody would like to have a look at that? That is a product that's got surface mount. It's been on the machines, and it has got quite a lot of components that have been fitted on the production line. What this section is doing here is examining the quality of soldering off that wave solder machine. So the operatives here will be looking to see that there's the right amount of soldered joints, any missing solder. Any components have to be fitted here that are susceptible to heat, because that gets up to 200 degrees, 220 degrees. Some components like diodes and certain crystals, can't subject them to that heat, so we have to fit them again manually. At this stage of the process, that printed circuit board's finished. It's got all its components on the board, and we've gone through a verification stage where we make sure that we're happy with the cosmetics. There isn't going to be any missing solder, any short circuits on the board. It is now ready to go into a testing process stage. Some of the boards are manufactured in panels. You can see that gentleman there, he's got one with about 6 on the panel. They're broken out. We have various equipments out here that break them out of the panels, because some boards are only that big. We might have 20 in a panel, 40 in a panel, and some boards are large boards themselves. Everything what you're going to see walking down here now is all about testing the product. The board's finished, all the components are, piece of test equipment there. This is an highly sophisticated in-circuit test process where you'll have to have a test fixture that's designed. It can cost £10,000. And then what we'll be doing is inserting the printed circuit board into the test machine, and it powers up all the circuits, and it either passes or it fails. We monitor very carefully the yields that we get from that process. This section here is still test, but it's functional test. That was just seeing if the circuit works. This is where we power up the actual product. Some customers give us a test rig, we insert it into the test rig, do all the connections and power up and make sure that it functionally works correct. We have facilities here. These are environmental chambers. So we have to make sure that the product not only works, but it can work at -20 and +40, because it might be going to the, the Arctics, or it might be going to, a lot of hot countries as well. We also put completed systems through an elevated temperature as well. So at this stage here, the printed circuit board is finished and it has been tested and has passed. Because anything that doesn't pass then goes for diagnosis. It eventually ends up here. This is our final inspection stage, where two things either happen. It's either a printed circuit board business only, like that product you saw there. That gets shipped to the gaming company and they fit it into their one-on bandits. So that will go from the final inspection stage to the packing area. The other products that are going into the systems that we're contracted to build for that customer will get put in storage. When I say storage, it's a holding area that it's available for the systems team. So as operations manager, one of my difficult tasks is making sure that I've got the product here just in time, not just too late or miles too early, just in time, because that's money tied up if it's here, sitting here for too long. What I'll do now is I'll take you to the Vega cell where we're actually assembling the product. So we started here, we've been round the process, and that is what we've produced. Okay? There are the Vega printed circuit boards that have just gone through that process that I've just taken you around. Okay? As I've said, these products now are waiting to be assembled into the Vega console, and this is where we're doing it. When we're in full production, it will be well, we'll multiply it as many that we need to get the beat rate, but initially it will be a three-stage build. We assemble it, we test it, and we pack it, and that's what you see here today. If you want to stand here. Quite simple. There's not that many ports in the Vega console. Wait a moment. Ian will take us through how it goes together. Hello. And Catherine there is doing the test process. So Ian's assembling it, Catherine's testing it, make sure it works okay, and the last stage then will be putting it into its final packaging. There we go. Start off with the plastics. Then we take the printed circuit board. Just make sure we get the connection right to the printed circuit board.
Ian, when you've got 5 minutes, take some apart for me, please.
Yeah, sure.
I need to look at the board.
It's very important to make sure that we get the routing of the cable and the console done correctly.
Special attention to that.
One. Yeah, one.
Catherine's now just starting the testing process. what that's involved there is checking all the buttons there. The software. Easy enough to get thousands in. It's a small console. Okay, that's the assembly. That's the test. And as we said, that the final part there is putting it into the final box.
Yes, please.
Okay, that's the process. So what you've seen there is the complete manufacturing of the printed circuit board and the assembly of the console itself.
Thanks very much.
Thank you.